Hey guys, my name is Tania Patel and welcome back to eCoreAcademy. I'm back with another lesson for our Algebra 1 course, and if you couldn't already tell by the title of this video, we're going to be talking about types of solutions today. But before we get into the lesson, I'd really appreciate it if you guys could like this video, comment down below, and subscribe to our channel. Also, do not forget to share this platform with others who can come join and thrive with us. Now let's get started. So, like mentioned before, we're going to be talking about types of solutions. As you can see in this picture, there are three types of solutions. Something called a unique solution, also known as the one solution, and that's what we're going to be talking about or referring to it as the most one solution. Then there's also the infinite solution set and the no solution. So when we're talking about types of solutions, you also want to be aware of what solutions even are. Solutions are just values of a variable that make an equation true. So for example, in the equation 4x plus 2 equals 10, what value of the variable x will make that equation from the left equal the right, making it true? It will be when x equals 2. And the way that you know the solution is that you will solve for the variable. And we've done this before, and you've had much practice from pre-algebra, so we're going to be applying those rules again here, and we're going to actually be talking about what type of solution it may be. I'm going to tell you right now that it is a one solution. X equals 2 is a one solution or unique solution, but I do want you to come back to the end at the end and maybe leave in the comments down below why is it one solution. And so now we're going to get into the notes. Again, remember that it's so much easier to understand a mathematical concept when we are actually using what we know and the information we know in practice. This is just notes. If you don't get it, it's completely fine. Wait till we get to the practice section, but do stick around and copy these notes in your notebook. So, like I mentioned before, there are three types: the infinite solution, the no solution, and the one solution. We're going to be referring to the unique solution from the cover slide as one solution. So, just a side note, but starting with the infinite solution, when I think of infinite solution, I think of an identity. Just because of the I and I don't know how that comes, but it does. But an infinite solution, or in an infinite solution, there are infinite solutions of equations because they're the same line. You'll understand this more when we get into practice. But then there's a no solution. No solution, I think of not true. That is when there are no solutions of equations because they are parallel lines and they never meet or intersect at one point. In other words, it's going to be that the two left and right results will not be the same. And they'll be numbers. For the one solution, there is a one solution of an equation because the two intersecting lines meet or intersect at one point. This is the one solution of that equation. That is when at the end it's a variable which equals a certain number. That's the difference. And then I do want to backtrack and give you this information. For infinite solutions, at the very end, after solving the equations, you will get the same number both on the left and the right. And that's how you'll know it's an infinite solution, mostly because it's an identity of each other on the left and the right. So now let's get into the examples. I'm going to show you a total of 8 examples, 3 of them which we know are going to be a certain type of solution. So we'll go over infinite, no, and 1, and then I'll give you 5 random, and we'll come together at the end to find out what type of solution that equation is. When the first step is to solve the equation, right? To actually understand what type of solution the solution is, we need to solve for the solution. And we're going to use our PEMDAS rules, and we're going to solve for the variable. And so here's our equation. I know that I see the parentheses. I know I'm going to just distribute that first, but I also know that we can start just combining the like terms together as we go. All right, so 5x minus 4 plus 2x minus 8 will simplify to be 7x minus 12, which equals, after distributing the 7 in the parentheses, it's going to be 14 it's going to be 7x minus 14 plus 2. Ignore that. All right, so we have 7x minus 12. We can't really simplify that any further, but we can simplify this section. So 7x, and the two like terms are the constants here, which will end up being negative 12 when they come together. And we can already tell that this side is basically, not even basically, they are the exact same sides. The information on each side is the exact same. So that's kind of where you see the identity idea come up. But if we're going to continue solving and isolating the variable, we're going to move the 12 to the right side, because we're going to put the variable on the left just for personal preference. That'll be 7x equals 7x plus 0. And then we will subtract this 7x and put it there to the left side. So it will be minus 7x equals minus 7x, right? When that happens, we know that it's going to be 0. Bring down the equal sign is equal to 0. And that's where you know that this is an identity. In other words, it's also an infinite solution. But this is a prime example of how you would see and how you can know that a solution is an infinite solution type. Now to the next example, we're going to be talking about no solutions. Same thing, well, not the same thing, but you will see how there's always going to be constant pattern with identifying no solutions. So like the Pearson, we're going to have to solve the solution, and we're going to have to solve the equation. And the way we're going to do this is, again, by following our PEMDAS rules. Let's just start. So there's going to be 7x minus 12, which equals 7x minus 14 plus 6. We're going to continue on, and then we're going to combine the like terms on the right side after distributing the 7, and we're going to get negative 8. They're not the same. They're similar questions, but they're not the same. We're not at an identity crisis here, but as we do solve for our variable, we're going to isolate this stuff. So we're going to bring this constant to the right side. 7x equals 7x minus 8 plus 12, which equals 4, positive 4. And then we're going to bring this 7x to the left side to put the x's together and isolate the variable, which is going to equal 0. Bring down the 4. Equals 4. So this is the end solution. 0 equals 4. But I guess you can tell that 0 does not equal 4. 0 and 4 are not the same. And this is a prime example of it being a no solution case. Again, that's because at the very end, both the left and the right side are numbers that do not equal each other. Therefore, there is no solution to this equation. So there is an example of no solution. You will always see at the end of a no solution type of problem or solution that there will be no similar or same number. The last example of a different type of solution is the one solution. And the one solution, we're going to still follow the same steps. We're going to solve for the equation. And I can see that we're going to distribute on both sides of the equation this time. So we're going to follow our rules, which we already know from algebra, pre-algebra. So it's going to be 4x minus 36 equals negative 4x minus 36. So solving, again, 4x equals negative 4x. Negative 36 plus 36 equals 0. and then adding 4x to both sides, it'll be 8x is equal to 0. Then we're going to solve for our variable x. We know that we just divide both sides by 8, and x equals 0. And this is a proper example of a one solution because for every variable, there is one number that corresponds to that variable that makes this equation correct. And that's why there is only one solution. So all the 3 examples I just gave you are basically going to be the normal rules that you will see when you're trying to identify what type of solution a solution is. And now we're going to get into our 5 practice problems. These are great practice problems for you. You don't know what type of solution it is, so what we're going to do for these 5 practice problems is that we're going to solve the equation, and we're going to come together and we're going to decide on what type of solution that is based on the notes that we took and based on the examples that we just went through. So let's do our excuse me. All right, let's just start with our rules, our PEMDAS rules, and our algebra rules. So we're going to start from the left side to the right side and distribute if needed. So there's 2x plus 8 equals 2x plus 3. So we already know that we're just trying to isolate the variable. So we're going to get 2x equals 2x minus 8 to both sides, which will be minus 5. Subtracting 2x from both sides will equal 0 equals negative 5. There are 2 numbers that are not the same. So what type of solution would this be? I'm hoping you said no solution. Not the same are the key words. No, not same equals no solution. So this right here, my friend, is a no solution. This equation does not have a solution. And that's what it really means when we say that the type of solution is no solution. So practice problem number 2, same rules, same steps, and we're going to start with distributing the 5. And it's going to be 10 plus 5x equals 45 plus 5x. We're going to start with subtracting 10 from each side. So it's going to give us 5x equals 35 plus 5x. I mean, no, we just got rid of it. Sorry, that's on me. We just got rid of that. So we don't have the plus 5x. We just subtracted 5x from this side to the other side. And so I'm sorry. That was completely on me. I went one step too ahead. I was right originally. There is a plus 5 because we have not yet gone with the variables and exchanging them. So sorry. We're going to continue. After we subtracted the 10 from both sides, we get 5x equals 35 plus 5x. Now we're going to subtract minus 5x from this side, and we're going to get 0 equals 35. This, again, is a case of no solution because these 2 are not the same. So here's another prime example of a no solution. And I am very sorry for the messing up, but for a quick review of the problem, we're going to first distribute the 5 on this side and get 10x plus 5x. Not 10x, just 10. 10 plus 5x, which equals 45 plus 5x. Next step is to start isolating the variable. How are we going to do that? Get rid of the constants and put them on one side, and get rid of the variables from the one side and put them on the other side. So we're going to put the variable on the left side. So we're going to start with getting rid of the constant on the left side, which is 10. We're going to subtract 10 from both sides, and when we do that, we get 5x equals 35 plus 5x. Now it's time to isolate the variable. to its fullest and subtract 5x from both sides. And when we do that, we get 0 equals 35. But when we're trying to find out what type of solution that is, we know that 0 does not equal 35, and therefore it is a no solution type of problem. That it was a quick review of this problem because I'm sorry to have made a mistake, but we did get it at the end, and that's all that matters. So now going on to practice problem number 3. We're going to follow the same rules. We're going to start with solving this solution. We're solving this problem for the solution. And we're going to solve for x. I think that's something that you might have heard more, solve for x. That's the same thing as solving for the solution. All right, so we have 9 plus 1/2 x equals 5x plus 1. There really wasn't anything that we could do right away, so we are going to start with our isolation of the variable. I think it'd be smarter for us in this case to keep the variables on the right side and the constants on the left side, because when we are subtracting a fraction from a whole number, it's much easier to go from subtracting a whole number from a fraction. So for that sake, we are going to keep we're going to isolate the variable to the right side. But before we do that, let's get rid of the constants and put that on the proper side. We know that we're going to bring the constants to the left, so we're going to subtract 1 from each side, and that's going to equal 8. 8 plus, sorry, that was, I wrote that incorrectly. 8 plus 1/2 x equals 5x. So the next step is to get rid of the 1/2 x from the left side and put that to the right side. So we're just going to subtract negative 1/2. We're just going to subtract 1/2 x from both sides, and that will give us 8 equals 5x minus 1/2, which is 4 and 1/2. 4 x. And this can also be known as 9 over 2x. So we can also say that if it's easier. But then at the end, we're just going to switch it again for personal preference, but we're going to keep it the same. 9 2 over x equals 8. And now we're going to multiply both sides by 2 to cross this part out, which equals 9x equals 16. Then we're going to divide both sides by 9 to isolate that variable for the last time, and x equals 16 over 9. We know that this is the solution, and this is not a no solution because we don't have two different numbers at the end that are not the same. Instead, we have a variable that has a corresponding number to it, telling us that that number is actually the solution of this equation. Knowing that there's only one number corresponding to that variable, we can successfully conclude that this is a one solution. Type of solution for this equation. So that was the first practice problem that we did with the one solution. So now let's see what the next two are. So same case, we're going to start solving. Now I'm going to let you do, instead of me telling you each and every step, I just want to see if you guys can solve it and get the same result as I get. So let's do it ourselves and meet back up here. I'm going to do it right with you, so. All right, so I'm done solving. If you guys need any more time, please do feel free to pause this video. But after having this solved, I think we can conclude that this was that we have two numbers at the very end that are equal to each other. They're the same, and same means identity, and identity leads us to infinite solution. So I think that it's safe to say that this type of solution was the infinite type of solution. Say if this was a 1 equals 0, we know that's a no solution, but 0 equals 0 is an infinite type of solution. So that's the first infinite solution that we dealt with in our practice problems. I'm hoping you guys got that. But like I said, to actually determine what type of solution each solution is, it's very easy. They kind of follow the same rules. So you just have to look at the rules and see which one pertains to what you're looking for. So we're going to do the same thing. I'm not going to walk you through the steps, but I'm going to solve it right with you. So let's meet up with other solutions. This is one of the fractions. So we do want to make sure that we're doing our work correctly here. I am done solving this problem. I am trying to write down all the steps that I can. So if you guys do need help, you guys can always reference back to my work. But if you guys are not done solving this problem yet, feel free to pause. But now we're going to try to see what type of solution this is. So the solution that I got at the very end was that x equals 7 over 3. It's a variable that has one corresponding number, and that's what I noticed out of this. So I think I can successfully conclude that this is a one solution type of solution, because it's just telling us that the fact that x, the variable of this equation, only has one solution, which is 7 over 3, it is that solution that will make this equation true. And it's as simple as that. But please do reference my work. I'm going to erase this now. And that was our last practice problem. So I hope that after watching this lesson, you guys can understand so much more on what types of solutions are and where they kind of come in hand, or where they come in like math. And I hope you guys get a more understanding of how exactly you're just using everything that you've learned from the past, such as solving solutions and trying to analyze what exactly you're doing. But this was one of the reviews from pre-algebra that you do want to remember for Algebra 1. So this hopefully was a review lesson. Again, if there was anything that you guys need help with, please do not hesitate to leave that in the comments down below. We'll surely get back to you. And I really hope you guys liked this video. I hope you guys enjoyed this lesson. I hope I could help you guys. But other than that, here is the website link of our account if you guys need to contact us, and our social platforms that you guys can stay updated on for eCoreAcademy. But do not forget to like and subscribe to our channel. I hope you guys enjoyed, and also comment down below anything that you guys may want to tell us, such as comments, questions, or concerns. But other than that, I hope you guys have a great day. Thank you for watching the video, and see you next time.